Have you ever stared up at the night sky and wondered about its deepest, darkest secrets? What if I told you there are monsters out there, so powerful that they can swallow entire stars and not even light can escape their grasp? These are black holes, the universe's ultimate enigmas. So, what exactly is a black hole? Imagine taking an object with incredible mass, say, a star many times bigger than our sun, and crushing it down into a space smaller than a single atom. This creates a point of infinite density called a singularity. The gravitational pull here is so mind-bogglingly strong that it creates a boundary around it known as the event horizon. Think of it as the universe's ultimate point of no return. Once you cross it, there's no coming back. To really get our heads around this, we need to think about space and time differently. Thanks to Albert Einstein, we know that space and time are woven together into a single fabric called spacetime. Picture a stretched-out rubber sheet. If you place a bowling ball on it, the sheet bends and dips. Now imagine something infinitely heavier. A black hole creates such a deep, steep well in spacetime that anything that gets too close can't help but fall in. This isn't just a pull, it's the very shape of the universe being distorted. This extreme warping of spacetime leads to some truly bizarre effects. One of the wildest is time dilation. The stronger the gravity, the slower time passes. So if you were orbiting near a black hole's event horizon while your friend watched from a safe distance, your time would tick by much, much slower than theirs. You could experience a few hours while decades, or even centuries, pass for the rest of the universe. It's real-life time travel, but only into the future. And it's not just time that gets bent out of shape. Light, which we usually think of as traveling in a perfectly straight line, also has to follow the curves in spacetime. As light from a distant star passes near a black hole, its path is bent. This effect, called gravitational lensing, can make stars behind the black hole appear in different places, or even as multiple images, like a cosmic funhouse mirror. Astronomers actually use this effect to map out where invisible black holes are hiding. For a long time, scientists thought black holes were cosmic dead ends, places where information and matter go to disappear forever. But the legendary physicist Stephen Hawking came along and turned that idea on its head. He theorized that due to weird quantum effects right at the event horizon, black holes aren't completely black. They actually emit a very faint glow of particles, which we now call Hawking radiation. This means that over an incredibly long time, longer than the current age of the universe, a black hole will slowly lose mass and eventually evaporate into nothing. So, are they just giant vacuum cleaners? Not quite. Black holes are crucial players in the cosmic story. Supermassive black holes, millions or even billions of times the mass of our sun, sit at the center of most galaxies, including our own Milky Way. Their immense gravity acts as an anchor, influencing the formation and evolution of the entire galaxy around them. They can trigger bursts of star formation or blast out powerful jets of energy that stretch for thousands of light years. But many mysteries remain. What actually happens at the singularity? Where our laws of physics break down? And what about the information paradox? If a black hole swallows something, is the information about it gone forever, or is it preserved somehow? Answering these questions could unlock a new understanding of gravity, quantum mechanics, and the very nature of reality itself. From warping time and space to shaping entire galaxies, black holes are far more than just empty voids. They are active, dynamic objects that challenge the limits of our knowledge and fuel our curiosity about the cosmos. They remind us that the universe is a place of incredible wonder, with secrets still waiting to be discovered. Thanks so much for joining me on this journey to the edge of spacetime. If you enjoyed this deep dive into the universe, don't forget to like, subscribe, and hit that notification bell so you don't miss our next adventure. See you in the next video.